come down also, which will position the gear right into this. And also, when the gear touches the end, there will be a mechanical trap that basically snap down this part of the gear pickup, which means it'll secure the gear into the pickup. And also, so when this piston retract, it'll basically come in this position, vertical to the ground, since there's a rod after the rod over there. Didn't do any calculations, but I think that would be possible. And then so this will be where the gear fitted in the robot. So this will be front or back of the robot, and this will be vertical position. That will be the horizontal position of the pickup. Right?
So our ball pickup is the brushes
slash rollers.
Yeah. It's not a vacuum. We're not using it. So this can function. Like we can just be driving and just figure out while we're going to get a gear. Put a gear onto the gearship. The cons, it does require an opening the bumper, and the reason why we did not do over the bumper intake is because that does take away from our volume. We thought volume is very precious in this game, so we wanted to make sure everything tries to stay inside the robot rather than trying to go outside. And so, cons, it would you have to make snapped parts to get to the shooter and other stuff. You'll see. We can go ahead. Oh, we can show it later. Okay. Next one, the shooter. The real shooter. You want to shoot fast. That's very important in this game since without the auto, you have to. Okay, so it's fast loading and
Okay, so this will be our pickup system. So basically, that will be Great. Zoom in a little bit. That's good. Okay, so basically, in this diagram, it basically shows that this will be the floor, and we're gonna have a roller that's brush over there, and the ball when we're running over the ball will be sucked into this cabin, which is slightly backward. This means the ball will roll automatically to the shooter without any mechanisms. And also, this is the top view of the cabin, and so basically, this place will fit a shooter, and we'll have the slanted all. We'll have the angle slightly in this kind of position, which means that all the balls, even though it's filled, it could all end up in the front of the shooter. And you think actually we can also fit one of the, is that what, 5? Yeah, I'll fit one of those things in there.
He was talking about the agitator I had.
So, cons, this is only one shooter, so it can only shoot one at a time, and it can deform balls.
Sorry.
As we can see, these balls can deform if you press on it, and I'm unsure how well the wheels will allow the balls to stay in shape. And then you have to shoot from a very precise place, as it's not fully rotating. Okay, I'll take it rotating at all. Sorry.
It could happen.
It could.
It depends. We are thinking about whether we should. It's still debatable in our conversation, but we'll see.
So
Here's basically our shooting mechanism. I think I got a better one in this one.
Speak up.
Okay. So basically,
If you look at the audience, you don't have to speak as loud.
so basically, these will be the wheels that turns, and as the ball gets sucked in there, it's on the board. That's a hard one.
we have the design of the robot data.
Anyways, it will be sucked in from the cabin by a series of wheels. We're thinking about belts, but then they move relatively slower. and we don't want to. We want the shooter to be as rapid as they could. So basically, we want to have a bunch of series of really small wheels that suck the ball right into the shooter and shoot it right away with these projectiles. And yeah, that's basically it. Martin, want to talk about it?
Well, you gained 50 points.
Yay!
Cons, we thought we couldn't come up with a great design for it.
Yeah, we did.
It was hard, you need very precise driving for it. And also, I'm unsure of how well the rope will hold up with a wheel running against it for a good 20 seconds at least.
She could slip.
And slipping.
Okay. It's really splendid, but I wish you could see. So, that would be the front view, and that would be the top view.
Is that a toilet?
It's a fire alarm. That is a Mickey Mouse.
Yeah, Mickey Mouse.
Anyways, it's not a toilet, just saying. So basically, no, it's not a toilet. Why would you want a toilet? I mean, toilet is for someone it won't shoot unless you're flushing.
You want to say
Anyways, okay. Okay, so this will be the top view of the robot. Basically, you have 4 wheels or more on the two edges of the robot, as usual, and you have the bumper around it. Also, this red thing right there, which we color the openings and the volume tanks and cabins red and the shooter, so that is more distinct. So you can see the ball coming right here and got stuck into the, it's not to scale this thing, almost not to scale, and it'll be stuck into this cabin and then got shoot from the end. And this place will be the one I drew will be the gear intake, and it will it will turn up, will rotate and position the front of the robot. And those two things kind of show for the 2 wheels of spinning, which will climb the rope. And I doubt it's gonna work. And we're gonna have a little opening to the cabin, which means we'll have this one-way gate, which means the rope's going to be feeding into the cabin. We don't need to have, well, I found out that's a good way to make that there's going to be no opening at the bottom of the robot.
And the cabin is slanted, so the wheels will be going more directly to the shooter.
True. Okay. That's basically it.
Why do you think there are going to be a lot of gears in the ground?
Well, the point is, you can always expect that there's going to be some problems.
So you're designing your robot.
And also the point is, you cannot get, you need to, if there's a bunch of balls or gears end up in the loading station wall, you can't really get to the loading station unless you push them away if you're doing the passive. But if you're using this active method, you can always pick up the thing from the ground.
So you're designing this robot to pick gears off the ground with the assumption that robots are going to miss from the feeder station during the gears layer.
Sorry?
You're designing your robot with the assumption that robots are going to miss getting gears from the feeder station. They're going to be gears right in front of the feeder station.
Or it could be balls that roll there.
We made it so that if someone drops it, then we can pick it up.
Or if there's anything, like if you have a bunch of balls on the right corner of the wall, you cannot fit your robot right in there.
You just drive through them because your bumper zone is.
Are we talking
shorter
about
than the
balls
so
or
you
gears?
just push them out of the way.
Well, yeah, you need to drive around and push them, and then drive back to position the robot.
Why not?
Yeah, originally we thought about putting gears on the ground, and then after looking at the amount of gears you get and the amount of gears you need to complete all 4 rotors, we noticed that you actually get 9 extra gears. So you can drop up to 9 gears in a single match. Yeah, until you
and your
what?
teammates.
So 9.
It's 21 gears on the team.
21, because you count the ones on the turret.
Still,
So you wait, 21, you need, 21, you need 12.
Yeah, you need 12 to complete.
Yeah.
But you need 12 to complete.
13.
Oh, and including the one starting the tower, so you get
That's
you get
13.
10.
Well, our gear design was similar to Spencer's originally, but then
Oh, and then the
on
tower.
miscalculation of the height of the chute, that's why we had to change it.
So, so the one conversation that you guys had was that you can always get a gear onto the ground. And that if there was a gear on the ground, there was a potential for it to block you from getting to the top.
And a couple of design questions. Did you discuss the drivetrain at all?
Slight.
I'm sorry?
Okay.
Tank drive. Okay,
Yeah.
that's, I'm just trying to take notes for everything, so, tank drive, okay, thank you. Nice job. One more, then we'll take a break. How about team number 7? So I know, guys, you want to discuss all this, but let's pay the respect to the team that's up there. Let's listen to what they say. Sure. Who's team 7?
Alex.
Okay. That's okay. Just need to step up.
Alright, there we go.
Posters.
Okay, yeah, allowed. If you can't see, you should just, you shouldn't complain, you should just go do it. I know, I keep telling you. Just do it. Guys ready?
Okay, so we are group 7. Team members were the people you see here, and then not Jack because he didn't show up. And a couple other people, but you know, I just want to give Jack some flack for that. But anyway. So in the process, we just started by establishing the scoring and etc. as most people probably did. Then we calculated the total points any source can give us within reason during the game. Discussed the scoring strategies and then estimated the average score of the third week which apparently, despite my protests, came out to 230. Personally, I think it would be a little more, but that's just me, and I'm always wrong. So, yeah, the breakdown you see here is 73 for auto, which is 2 robots cross the line, 1 gear, which I can't stand, and 1 robot gets 10 in the low goal, which I also don't like. Anyway, I have a lot of opinions on this breakdown. There's 80 points for the gears, which is actually kind of reasonable. And 50 points for climbing, and then 24 to 30 points for the shooter, or for balls, actually. And we believe that gear and shooter will make the most difference in the game.
So, gears are the highest.
Mark, face the audience. Speak
Yeah,
up.
you have to be really loud.
Gears are going to be the highest scoring piece of the game. We think because we think we're going to get at least 2, definitely 2 rotors independently. maybe 3 even, possibly. So that could be, like between 120 and 140 points right there. And I mean, climbing is the second half. So gears and climbing are two highest priorities. But shooting is going to be what separates us from like what other teams do. In that, I think many teams might not have a shooter, maybe, or just basically we can cap out on points with gears and climb potential. But if we have a shooter, we always have something to do, and it just put us over the top of the six. Maybe our other teams will shoot as well and get another one. Although shooting, yeah. But since our strategy revolves around delivering gears, we don't really want to take away time from that cycle by having to go out of the way to get the ball or fuel and shoot. So instead, we figured that we kind of have a sort of vacuum without the vacuum part, and that we was kind of on the way to get gears from the shooting station. We should be picking up fuel the whole time, and that maybe while we were delivering gears, we'd be also shooting. But at the same time, that way we take away no time whatsoever from delivering gears. But yeah. So pretty much covered all this. And the last part is the HVAC and usability. We didn't really go into our drive too much. We just wanted to focus on the series manipulator computer. But we think HVAC would be just good for speed.
Okay, so keep that screen up. I need that screen. The screen's black and it's nice. Thank you. So
It's not good tip to use.
These are high quality slideshows. We prepare.
Wait, guys, don't use the packing tape.
Don't diss my drafting skills, alright? Don't diss my drafting skills. So this would be our active gear manipulator. Sorry. So this is our manipulator. It is sort of like yes. It is a crescent wrench basically that would be able to angle. So this is our top view here. There'd be rubber on the outside and a worm gear which would close it together. Probably only one side, like an actual crescent wrench. What are you laughing at, Benji? You're laughing at me. You look ridiculous, and I know I look ridiculous. Anyway,
We all look ridiculous.
that's fine. But anyway, there's a plate in the back, like maybe 16, maybe 8-inch. With a hole in it for the peg itself, so that the gear is there, and you clamp around it, and then you back up to it. This is in the back of the robot. You back up to the peg, you stick it on the peg, and then you release the mechanism and drive forward. Well, once you're done shooting, because that's also where we shoot from. And this is just the front view. There's the plate here, the 2 manipulator arms, and then there's another plate over here to keep it from falling out the bottom. So yeah. And then we have our shooter.
Done with free hand, but somehow gone we'll see the scale. Okay, so this is our intake and our shooter design. So here we have this would be a roller inside the robot because we want to maximize the space that we can dedicate to, say, the hopper. And so we have a slightly compressible roller, maybe rubber, maybe foam. And basically it would take the ball in and use the compression right here rather than on the ball. It's hard plastic rather than foam, which is what we had last year. And so it would take it in and basically shoot the ball up through here, and using the momentum gained from this roller, it would shoot it up and over here like a faucet, basically.
So that way you can have more space dedicated to the hopper without getting in the way of the shooter. Because you have the wall that blocks the balls from getting them get back into the intake. So these are the hoppers in the center of the robot. We're not exactly sure how we're how we're going to do an agitator because we want to be able to remove that plate so we can get to the electronics we're probably stored below there. But that is not
Just
so.
so think of an agitator.
But I'm sure
The
that
entire
what
box.
is.
Oh, good.
So over here, oh actually one other thing about this is that we're thinking of having two intakes, probably one on each side, so that you can drive forward or back to get balls. We're thinking of having an H drive so you can have go forward for the to get away from the gear and forward and back for this because they're not going to be on the same sides. And here, this is going to be on probably one of the third sides of the robot, so not on either of those sides. So the propper is right there, and so we'll have the balls dropped in down here into the speed wheel, which will bring the ball around here and shoot it up through a tube, and so that way we can shoot across the robot and we can get more height, so it's harder to block. At the near closer to the end of the tube, this is not the scale by the way, there will be a couple wheels to give it extra speed and some more spin so that we can get more consistent shots. We may have adjustable, the pipe be adjustable itself, as well as the speed of the intake and the final shooter wheels be adjustable to speed so that we can